Good afternoon, I am Mr. Ish. You are joining me for this video here on transversal line and the angles that come about it. What exactly is a transversal line? At any instance where you have two parallel lines, let's draw like a railroad track. Here's my line A and line B. A is parallel to B. At any point you have a line which cuts across or intersects across, and all these three lines are in the same plane. Nothing is coming in or out of the board, they're all in the same plane. Well, this cutting line, this intersecting line is called the transversal line. The beauty of transversal line is that it gives you an excellent opportunity to examine the variety of angles that result: opposite angles, corresponding angles, supplementary angles, even complementary angles if the transversal line happens to be at a 90 degrees or at a perpendicular. Anyhow, our question will be this: if we are provided a single angle right here, and we'll call this angle 110 degrees, we have to find all the remaining angles. Any angle that arises from this diagram, we have to find them all and we'll identify them. So let's do it. When you're looking at this 110 degrees right over here, if you look across it, you know you have a straight line and you have a supplementary angle. These two angles would add up to 180, and then you know this right here should be 70 degrees. If you look opposite to this 70 degrees, you know by means of this intersection you have the opposite angle, which must always be equal, and that's another 70. If you look at from this 70 right down here, you have two corresponding angles. Because you have a parallel line, you develop a corresponding angle, and that right here must be 70. Opposite this 70, you know it's going to be another opposite angle which must be equal to it. When you look at this 110 degrees and you look opposite to it, you know you have the opposite angle which must be equal across an intersecting line. From this 110, if you look down here, this and down here, right over here, you have a corresponding 110 degrees which adds up, and you can verify that this right here is a straight line. These are supplementary angles equaling to 180. Looking across and opposite, you have the opposite angle which must be equal, and we are done with this exercise over here. And it wasn't too hard because you have an excellent opportunity to look at corresponding angles, supplementary angles, opposite angles. Now let's modify this a little bit and we draw another line. We'll call this line C, we'll call this D. Now the C and D lines are parallel to each other. Given everything we already know, we can continue this. With that one angle right here, we can fill up the rest. This angle right here and this angle right here are the two obtuse angles, and they're corresponding, so this must be 110. This 70 and this 70 are corresponding angles, or you can say these two are supplementary, they add up to 110. And likewise, you can fill across now. That's the opposite angle. Corresponding to this angle is down here, 110. Opposite to this is 110. Opposite to this 70 is this 70. Right, and corresponding to this 70 is the 70 down here, and opposite this 70 right here you have the 70. You can also look at the Z angle effect, as I call them, a Z angle. Let's show you right here. Here is a Z angle forming. If this is 70, that's 70. Here's another Z angle. Here's a 70, here's a 70. And you see likewise you can do a opposite Z. This way and this way. You have 110, 110. From here and here you have 110, 110. So you have a whole variety of angles which show up because of the transversal line, and just given a single angle and the fact that lines are parallel, you can develop and understand everything else. Alright, now let's look at this example. It's a modification. This right here is not a true transversal line anymore, because a transversal line is a line which intersects two parallel lines. Previously A and B were parallel, but here A and B are not parallel, but we can still use some knowledge we have attained and gained so far and figure these things out. If this angle right here ends up being 40 degrees and this angle here, we'll call that, well, it looks like a right angle, but we won't say it is. We'll say this right here is 85 degrees, and nothing is drawn to scale. We have to find all other angles. Because we don't have parallel lines, you need now two angles at least to figure and finish everything else. And that's the question: finish all the angles. Since we have no parallel lines here, we needed at least another angle. We're looking down here. If you look opposite to this 40, at any point you have two intersecting lines, the opposite angles at least come up and you can use that. But because we have no parallel lines, you're not going to have corresponding angles. But in this specific scenario, you'll always have opposite angles and you'll have supplementary angles. Supplementary to 40 right here would be 140, because you have to add up to 180. Opposite to this 140 should be another 140 that's equal. Opposite to this 85 right here, you have an 85, and then you know you can do supplementary angles, but there's no corresponding angles forming here. 85 and 180, you know that's going to be what? It's going to be a 95. Opposite to this 95, you'll have another 95, and the picture is complete. With that, we'll end this video. So keep what you've seen in this video in mind. Transversal lines are really involved with parallel lines, an intersecting line affecting a parallel pair of lines. Here we don't have a true transversal line, but we can still utilize some benefit of procedure you understand and learn from the transversal line. And that'll be it for this video. Thank you for watching. Have a nice day.